Hey guys, some folks are having trouble with transversals. I'm going to try to go through those a little bit. So transversals are these. You have two parallel lines, and they're usually indicated that they're parallel because there's these little ticks on it that show that they're going the same direction. And there's a cut here called a transversal. That's this big long guy right here. Now what this does is it creates a system of big and small angles. There's an obtuse angle right here. I'm going to call it A. And there's a similar obtuse angle right here. I'm going to call it B. These are in fact the same size. And here A equals B. Now there's another angle right here, angle C. A and C are literally exactly the same. If you think about it logically, if it was cut by a transversal at the same angle, this should be C should be the same angle as A. So these ones also equal C, and they also equal this other one, D, because same logic. C and D are called vertical angles. A and B are also vertical angles, but the system of A and C are what are called corresponding angles, meaning they're in the same spot on two different locations. This is also true for B and D. Okay. Now, I'm going to go ahead and change colors. Stop dropping my pen. Let's grab blue. So we have another system of angles. I'm going to call this angle E right here and angle F. This follows the same logic. E equals F because they're vertical. And you got G and H. G also equals H. Also, E equals G. Same logic. There are corresponding angles, and all that system kind of follows. So there's really two big sets here. A, B, C, and D. And E, F, G, and H. Okay. Now, there's also a system that's called alternates. There's alternate exterior angles. So those are angles that are on the outside exterior, and they're alternate, meaning they are inverted to each other. Meaning these guys, we know they're equal, but they are called alternate exterior angles. They're also alternate interior angles, meaning on the inside, like this. Okay. So that is that. Now, how to actually work with these angles? You got to know your systems of 180s. For this. A straight line, as you know, is a supplementary system. So a straight line here is called supplementary, and that equals 180. So in this system, if you have 100, you know that this one over here, call it x, x has to equal 80, because 100 minus x, sorry, plus x, pardon me, equals 180. You can then subtract 100 from both sides. So x equals 80. If you can set up the equation, you can solve it. Okay. Now that also works for here. If you have one that's like 40 right here and x, this is also a straight line, which means this is also supplementary. So 40 plus x also equals 180. Again, same subtraction. X should equal 140. Okay, cool beans. Now, these can be mixed and matched and combined and all kind of weird stuff like that. So the way this might work out is you'll have something like 3x plus 1, and you'll have 2x plus 9, and they'll say find x. Like, wait, these don't relate, do they? But actually, yes, they do, because if this equals 180, right, that's supplementary, meaning this is a straight line. Since this one right here is the same as this one also must equal 2x plus 9. So you can logically conclude that 3x plus 1 plus 2x plus 9, the two angles together, equal 180. Now it's a matter of just combining your like terms and just solving away. Top of my head, I don't know what 170 divided by 5 is. I might have to use the calculator, or just do side division. 30 and then another 20, so that's 34. I know, be impressed, right? So, there you go. That's how that works. Oh, didn't mean to do that. I apologize. Now, similar system works if you have something like 4x and you have plus 20, and then you have like 6x over here. Okay. Now, on the surface, these don't look like they are related. Or do they? These are the alternate exterior angles, meaning this one has to equal this one. Because these are vertical, I'll call this angle A, and angle A and 6x are the same thing. That means that 4x plus 20 must equal 6x. Now this gets into a little bit of more advanced algebra because you have to bring all your x's to one side, all your numbers to the other side, kind of mix and match a couple things. So if I were you, I would bring all your x's to one side via subtraction. Or you don't combine like terms, but they're on different sides of the equation. But you can move them using subtraction and addition depending on the need. Now you have 20 on this side equals 6x minus 4x is 2x. Divide by 2, x equals 10. You can make that conclusion with some basic algebra. That should help most situations. Now, what happens if you have a triangle? Never mind. I'll say it for